Warm greetings from Rajiv Institute of Technology, Hassan. Dear participants, good morning to you all. Today is the last day of our 3 days virtual FDP on data science and networking, organized by Department of Electronics and Communication Engineering in association with IETE Mysuru Center. Dr. Yashwanth N is today's our resource person. A brief introduction about Dr. Yashwanth. He's working as assistant professor, senior scale in the Department of ENC, Manipal Institute of Technology, MAHE, Manipal. He has completed his PhD from BTU in 2020, has more than 10 years of teaching experience in UG and PG streams. He has authored more than 15 research papers in international journals as well as in conference proceedings. His research interests include wireless sensor networks, signal processing, VLSI, communication systems, and antennas. He is editorial board member and reviewer of many international journals and conferences. He has 4 patents granted under his name. He is a senior member of IEEE and executive committee member of IEEE Bangalore subsection, IEEE Computer Society Bangalore section, and IEEE Young Professionals Bangalore section for the year 2022. Yashwanth, we are very much pleased to have you as our resource person. We shall continue with the session now.
Yes, good morning all. Thank you, madam, for the introduction. Before I start, I would like to thank the management of Rajiv Institute of Technology, the principal, Dr. N. Ramakrishna, the HOD, Dr. B. N. Arvind, and the coordinators for organizing this advanced level FTP for us. Okay, so I'll just share my screen. Please, anyone just confirm whether you can see my screen. One sec. I believe you can see my screen.
Yes, Yashwanth, it is visible.
Yes, thank you for the confirmation. Yes, let us continue with today's topic. So I am here to convey some information regarding underwater acoustic sensor networks. So in that, basically, what are the different advances which are happening in underwater acoustic sensor networks. So whenever I say underwater sensor networks, it reminds me about the PhD, what I had done. But as of now, I am interested in other areas as well. But this acoustic means sound communication. So since underwater or in water, we cannot communicate via RF, radio frequency, or optical in some cases. We try to communicate using acoustic signals. So that is what we do. So you can see I have put this underwater slide. So here you can see some fishes here. So they usually try to communicate using acoustic communication. So that is how the communication will happen underwater. Yes, I'll tell you the overview of my today's presentation. I'll be starting with the introduction. I'll be introducing the basic concepts of underwater sensor networks. I'll be explaining the design challenges because it is not like a terrestrial environment here. Since water poses many challenges to us, we have to be very cautious, I can say that, while designing the network, okay, the sensor network to be precise. So, and after that, I'll be going through the communication architectures for UASNs and the UASNs working with the different layers I'll be explaining, that is with MAC layer, that is medium access control layer, network layer, and transport layer. So how these layers can be utilized for our UASNs, I'll be giving an overview of it, and some of the open research issues. Since it is an FDP, so I will try to come up with some research gaps in this domain so that the other researchers, aspiring researchers, can carry out research in these areas. Because as underwater, the research areas are also unexplored here. So you can use these research gaps and pursue your research. It can be your master's or PhD or PDF, whatever it is. Okay, so I'll be starting with the introduction here. So basically, underwater networks of sensors have the potential to enable unexplored applications. So we have some applications like oceanographic data collection. So where we try to collect the data which are beneath water or the below the terrestrial environment. It is used for pollution monitoring. So we know that through or in our water seabed, we try to extract many resources which are useful for our day-to-day or our societal benefits. So it may cause pollution monitoring. We have some applications like offshore exploration, and we can also prevent the disaster by using underwater acoustic sensor networks. And it is also useful for assisted navigation, so we can have a proper path before reaching the destination. That is very important, because in water we don't know where obstacles are, or at what intensity the obstruction or the obstacle is there and all. So that's why we can use this for assisted navigation as well, and also for tactical surveillance. So many of the applications we have in this underwater sensor networking. So we basically, as I said in the initial slide, we go with acoustic networking when we consider this domain, because only acoustic networking gives a better or efficient communication medium in water. So this all the applications, whatever I have mentioned in the second point, is obtained or achieved through acoustic networking. Yeah, we can also go with autonomous underwater vehicles, where the underwater vehicles will move from one point to another point within that particular specified area, where this vehicle will try to collect the data and send it to the offshore uh, server where the processing will happen. Okay, so I'll be showing you some 2D and 3D network models where we are able to achieve all these concepts. So I'll be showing you those slides as well. And I am keeping this session equation free. Why? Because see, when I have equations, there will be graphs, and to analyze the graphs, we need to know in-depth knowledge on these kind of topics. So I'll be touching the overview of acoustic networks. So these potential applications is made viable by enabling communications among underwater devices. So these consist, that is, whenever we talk about UWSNs, it consists of sensors, it consists of vehicles, sensors, vehicles, which vehicles are nothing but the autonomous underwater vehicles or unmanned underwater vehicles per se. So these vehicles are deployed in underwater, and networking will happen in acoustic medium for the different monitoring tasks or the different applications which I mentioned in the previous slide. Moving on, uh, these are some of the applications of using UWSNs. So the first one is environmental monitoring. So this UWSNs can perform pollution monitoring. It can be chemical, biological, and nuclear, and also it can have ocean current and wind monitoring under the same environmental monitoring application. And also it can have biological monitoring as well, such as tracking of fish or microorganisms and so on. So all the human activities, environmental activities, can be explored under this application. So when I come to undersea explorations, so underwater sensor networks can help detect underwater oil fields. Okay, because we are now short of our resources. We need to explore more on our resources to survive uh, for long. So that is why we can have undersea explorations, like exploring the water, oil fields or reservoirs, determine routes of laying undersea cables, because now we are planning to connect all the communication in air. That is correct. That is through satellite, but some communication should happen via cable to other countries. So we need to underlay the cables so that we can have a proper communication. Okay, and also it can be used for disaster prevention. So where the sensor networks that measure seismic activity, that is, it can be an earthquake or any other tsunami kind of thing. So it can measure the seismic activity and give the warning to the coastal areas. I stay in a coastal area now. Okay, so it will give the warnings to the coastal areas or study the effects of submarine earthquakes and so on. So all that is one of the application. And next is seismic monitoring. So we frequently, if we do the seismic monitoring, it is of great importance in oil extraction. Okay, so from underwater fields to assess field performance and so on. It can be used for equipment monitoring. So whenever we deploy is placing an expensive equipment in water environment, which is helpful for our network. So that kind of detection and monitoring is possible by using the sensor networks. We can have an assisted navigation where sensors can be used to identify hazards on seabed, locate dangerous rocks. So locating a rock, I think we know a movie called Titanic, where a iceberg hit the ship. So if we had assisted navigation at that point, we could have avoided that, but we could have lost the movie. Okay, so we can go with distributed tactical surveillance, where the AUVs are fixed. Okay, and the underwater sensors can collaboratively monitor the different areas of the seabed. And finally, we can go with mine reconnaissance, where the simultaneous operation of multiple AUVs with acoustic and optical sensors can be used to perform the rapid environmental assessment. So whenever I say about sensor, so sensor is having many different components, which I'll be showing in the upcoming slide, where it will try to extract the real world information and convert it into electrical signals, which is understandable by the sensor node, and all the processing will happen in a controller. And finally, it can be we can have a memory also for it, and finally we can have the transmission of the data after processing in real word format and so on. Okay, so these are some of the applications when we try to obtain an information on underwater acoustic sensor networks. Okay, let's move on. And also, I want to convey one thing. If you have any doubts in the middle, you are always welcome to ask. Okay, so you can interrupt me in the middle and you can ask. And okay, moving on. So acoustic communications are the typical physical layer technology in underwater networks. Okay, so since, as I said, there are three types of communication which can happen in underwater environment, but not that much feasible there. The three types of communication can be the radio frequency, the optical communication. I'll just write optical communication, and finally the acoustic communication. Okay, so since the RF signals cannot transmit the information for a longer distance, we try to avoid RF communication. So yes, RF technology is very good in terrestrial environment. All the mobile phones are the electronic devices what we use are performing very well because of RF, but in underwater, the RF attenuates. It doesn't go for a longer distance. That's why we try to avoid RF. And yes, optical communication is very nice. It has a higher speed, everything. Okay, so, but the thing is, same thing happens here. It doesn't go for longer distances. We need to have a pointed beam so that it should reach the destination, and it is highly impractical in water environment because the sensors will be always moving from one point to another. Because it is a water environment, the sensors tend to move because of the water movement, or fish movement, submarine movement, and so on. So also here also we try to avoid this optical communication. That is why we go with acoustic communication, but we have disadvantages here as well. But the thing is, we at least convey the information to the other end. So finally, yeah, it is slower. Yes, the acoustic communication is slower. Yes, I agree. The bandwidth is very less. Yes, correct. But finally, we try to convey the information. So that is what is very important, because all the other techniques are not that much feasible in water environment. But if we have proper modeling of RF and optical communication, yes, it is possible to use these two technologies for underwater explorations in the future. Yes, that is possible. Right. Moving on. So there is a traditional approach called ocean bottom or ocean column monitoring. Okay, so where the waterbed is deployed with sensor nodes for all the monitoring for the different applications what I just said. So, but the problem is we cannot get the information properly because the information may be present here, and because of the limited power supply, the information cannot come to this sensor, and we cannot extract the information properly. There may be some errors and so on. Okay, so all those problems may happen in our traditional approach of underwater explorations. And also when the power supply dies, because frequent replacement of batteries are is not a easy option in water environment. So again, this node, when it loses its power, replacement is difficult. So we need to operate with only the remaining nodes. So again, there are a lot of problems in underwater environment. That is why I said we have a lot of challenges. We have some design challenges which are unavoidable, but to have we if we have a proper modeling, yes, surely it is possible. Fine. Yeah, these are the disadvantages if we have the traditional approach. That is, if we have the traditional approach, it is with respect to the previous slide. So there is no real-time monitoring. So the sensors, the below sensors will obtain the data. These sensors will obtain the data, and we need to wait for some time. We need to take the sensor out from the water environment, put it or connect it through a cable to a computer, and extract the information. So all this is not possible. So that is why I am saying no real-time monitoring, no online system configuration. We cannot have a modifications in the sensor remotely, we need to take the same thing, take the sensor, connect it to a cable, do the modifications, and put it back. So that is also very like it is a problem for traditional approach to be present here in underwater acoustic sensor networks. And yeah, again, failure detection may happen because of some damage in the circuitry, because it's in a water environment. And if the water goes into the circuitry, there is a problem in the circuit. And if the power supply dies, there is a problem in the sensor again. And finally, this poses a lot of problems. Okay, so that is also, and as I said, since I'm talking about power restriction in the sensor node, it is having a limited storage capacity. So these are the advantages, some of the advantages of our traditional approach. That is why we come across with acoustic communication. So where we have the sensor nodes pointed are placed at different heights, and we can obtain the data, and we can have more number of nodes and so on. So that is, I'll be showing a simple 2D and 3D environment for your reference. Okay, so moving on. Yeah, these are some of the design challenges I was talking about. So the available bandwidth is severely limited. Okay, so because of that, the transmission speed of signal in water is only 1500 meters per second. So this is very less compared to our optical or RF communication. Optical, what is the communication speed? It is 1 Gbps nowadays, correct? Gbps nowadays, or it is 10 Mbps. So very big bandwidth is there, very huge bandwidth is there. But in water environment, it is very limited because the communication will happen in acoustic medium. That is 1500 meters per second. So yes, the second point, the underwater channel is impaired because of multipath and fading. Okay, so we may come across with multipath and fading from a single sensor node. So multipath is having multiple paths, so that the actually expected receiver will not receive the message properly. So and fading also will happen because it's a water environment, because of the scattering properties inside water, because we have many impurities in water. So because of that impurities, or those impurities, we may lose the data. Okay, and yeah, propagation delay is also there in water environment, and it has a high bit error rate, and it temporarily loses the connectivity in shadowed. Shadowed is a deep water environment. So if consider this as the shore, and this, if it is between 100 meters, for instance, it is called as shallow water environment. And if it is below 100 meters in a water environment towards, that is the depth I am saying, then usually it is called as deep water environment or shadow zones. Okay, because see, when we go deeper into the water environment, it is completely dark. Okay, so it is highly impossible to have a proper communication or replacement of sensor nodes, or installing of sensor nodes, replacement of batteries, very difficult. If it is shallow water environment, we can take out the data, the circuitry of the sensor node, and obviously we can replace, and so on. Okay, so these are some of the design challenges which we need to consider when we think of UASs. Yeah, underwater sensors are characterized by high cost because of small relative number of supplies. Because there are very less manufacturers of underwater sensors, because it is not widely used as our RF sensors. So that is why the cost is very high, and battery power is limited, and usually batteries cannot be recharged. It is placed in water, we cannot take out at all times. We can have an IP address for it, we can locate it properly, but it is again cost effective, or it induces many more cost. So that is why it is not a feasible option. So yes, underwater sensors are prone to failures because of fouling and corrosion, because it will be having a circuitry when the salt water, if it mixes with the sensor node, obviously there is fouling and corrosion. Yes, moving on. So yeah, I will point out some differences with the terrestrial sensor networks here. So terrestrial sensor networks, that is above land, okay, above this land, the terrestrial sensor networks are costly. Cost wise, it is very less. Deployment is very easy in terrestrial sensor networks. The power can be managed properly because since it is above water, the replacement of battery is possible. The memory can be high because we can have a bigger sensor node, bigger box, so that we can have a bigger hard disk or any RAM or ROM or anything, and it also has correlation. Okay, we can have a very good synchronization with the sensor nodes which are placed above water, and while the readings from terrestrial networks are often correlated, so this is more unlikely to happen in sensor nodes because it is placed in a further distance. So correlation will happen in terrestrial sensor nodes because we have more number of sensors there. So these are some of the differences of underwater sensor networks with terrestrial sensor networks. So I want to convey here again, terrestrial sensor networks are placed above land, underwater sensor networks are placed below water, okay, are deployed below water. Yeah, so this is a generic diagram of an underwater sensor. So we have some different blocks here. So the sensor will have or collect the information. The sensor will collect the information and it converts the real world data into electrical signals because the circuitry will not is not able to identify the real world information. So a transducer can be used to convert the real world information into electrical signals, and the CPU on board will onboard controller will try to analyze the information what it has got, and if it wants, it can store it in a memory, or it can directly send the information through the acoustic modem to the other sensor network. So obviously we need a power supply for this. So this can be the path. Sensor will sense, the sensor interface circuitry will convert into electrical signals, and the CPU onboard controller will do all the processing, and the memory can be there to store the data if it is needed. And finally, after processing, the acoustic modem can give the information or send the information to the other sensor network. So this is one of the generic underwater sensor block diagram. Yes, so there are some factors influencing underwater protocol design. So the factors like transmission loss. So transmission loss will happen whenever we are considering a sensor. So even it is a terrestrial or underwater, loss will happen because we are completely relying on a hardware. Okay, it is not a human. So human errors will also be there, but anyhow, so sensors will make mistakes while transmitting, and transmission loss will happen. There will be noise in the water environment. There is multipath, that is, the signals can go to different sensors, and the actual intended receiver sometimes may not receive. There will be Doppler spread because, again, as I said, the receiver may not receive. The information go to other sensor nodes, and high and variable propagation delay may be present. So with respect to Doppler spread, we use Doppler this one concept, Doppler scan or communication or whatever it is. So the frequency spread can be significant. Okay, when it is compared to underwater acoustic networks. So because of this significance, so it may cause degradation in the performance of digital communications and so on. So that is why the data rate, everything is a mess there. Okay, so all these factors determine the temporal and spatial variability of acoustic channel. So we need to take care of all these cases by designing a proper model or coming up or proposing a proper model so that all these problems will be avoided. Yeah, these are the typical bandwidths of an underwater channel. So whenever the range between the sensor nodes, I want to say sensor to sensor node. Okay, if the range is 100 kilometers, the bandwidth is very low. So if it is having the distance, if the distance is very less, the bandwidth will be obviously high. That is, it will be more than 100 kilohertz. So depending on the distance, the bandwidth will vary because the same thing happens for terrestrial neuron. This is just a box where I try to show the different ranges and the effect of bandwidth on those ranges between the sensors. So consider this as sensor 1 and sensor 2. So this may be the problem here. Okay, so yes, moving on. Yeah, these are the different challenges posed by underwater channels. So I think I have told a few. So here, the transmission loss will happen. So underwater transmission loss describes how the acoustic intensity decreases as an acoustic pressure wave propagates. Okay, so to the source. So the transmission loss will happen, and the noise, yeah, it is everywhere because whenever we have equipments, electronic equipments, the noise will be there. Okay, so noise can be man-made noise and or ambient noise. So the man-made noise can be the machinery noise like pump noise, reduction gear noise, power plant noise, or shipping activity, animal cultivation. So all those things can be a man-made noise, or it can be ambient noise. So which is there present in water, like seismic phenomena or biological phenomenon. It can be movement of water, including tides, currents, water currents. I mean, water storms, wind and rain. Everything may have noise in it. So because of noise, yes, we may lose some of the data. Different problems may happen in communicating. Okay, and next is multipath. So multipath propagation may be responsible for severe degradation of the acoustic communication signal since it generates ISI. Okay, intersymbol interference. Because of this, the ISI will happen. And yes, high delay and delay variance will happen because the propagation speed is very low. That is 1500 meters per second. I said that. Okay, so previously. And also Doppler spread may happen because this may interfere with the receiver end. Multiple signals may be received to a single sensor, and the sensor will not able to make out the signal which is intended to receive or which is sent from the actual sender. That is the problem with the Doppler spread. So yeah, most of the described factors are caused by chemical, physical properties of water medium, such as temperature, salinity, density, and spatio-temporal variation. So all these problems are possible, are available in underwater acoustic sensor networks. Okay, moving on. Yeah, I was talking about this communication architectures. Okay, so these are the different communication architectures. I'll be showing three architectures here. So one thing is, uh, yeah, I'll place it here better. Okay, so we have two types of communication in 2D water environment. One is vertical link and another one is horizontal multi-hop link. Okay, so vertical link is between the cluster head. I'm just marking cluster heads here. Okay, between the cluster heads and the surface stations. So you can see the symbol here. So the communication is happening from the cluster heads. So I'll tell you one thing here. I'll just explain one thing. So we have two types of sensors. One is the normal sensors, I'll write it as NS, and another one is the heads. Okay, it can be like the head of a department who manages all other faculties. Okay, so in this case, the cluster head will be extracting the or gathering, I can say, will be gathering the information from the normal sensors and trying to pass it through the surface station. Here it is present. So the head will try to get the information or fetch the information whenever it is available, and it will send to the surface station for collectively having the data from all the different cluster heads what we have. So consider we have three cluster heads, 1, 2, and 3. So all three are trying to send the data to the surface station. The surface station, which is placed in the water, that is above water, which is floating, we can say, is will send the information to the surfacing, and through wireless communication medium, it is sent to the actual server. Okay, where all the processing, all the segregation, all the bifurcation or different processing will happen. Okay, so what we can see here, we have different sensors, that is UW sensors. We have gateways, which are known as cluster heads. We have surface station and surface sinks. Okay, so surface sinks connect with the satellite to send the information, or we can say internet if you want, and send the information to the processing center. So here, the from cluster head to the surface station, we have vertical link. We have vertical link, and from the regular sensors or the normal UW sensors, the information passing is in the form of horizontal multi-hop link. What is multi-hop? Multi-hop is a condition where the sensor is trying to communicate with the gateway in a multi-hop fashion. Consider this sensor is not directly, I'm marking here, this sensor is not directly linked to the cluster head or the UW gateway. So what it will do, it will send the information to the neighboring sensor first, and that sensor will send the information to the UW gateway. So this is how the communication will happen. So that is why it is called as multi-hop. Multi-hop is nothing but hop is jumping, okay, or sending the information in hop by hop fashion. Okay, the information is jumping from one sensor node to another sensor node. Okay, fine. So yeah, we saw that 2D underwater sensor networks, which is not that much comfortable in having a proper communication in water. That is why the uh, uh, discoverers discovered a 3D water environment where the UW sensors, that is the normal sensors, are placed are made available to float at different lengths. Okay, different lengths. So the anchor, same like our ship, a ship will be having an anchor so that it can stand at a particular location. Same like that, the sensor nodes are anchored to the water bed so that it can collect the information at different heights and pass it on to the surface station. But the problem is, again, because of this anchoring, sometimes the sensor may move in this direction, or sometimes the sensor may move in this direction. So if the information is available here, okay, if it is available here and the sensor is moving here, then the information is lost. Okay, all those practical issues are there when we encounter this kind of architectures. So that is why we have a modified 3D architecture with the help of an autonomous underwater vehicles. So this AUVs can function without cables or remote control or any wires, and therefore at different levels it can move, same like our drone. Okay, so drone is trying to collect the pictures of different areas in that is above water, that is in terrestrial environment, and it is linked to your internet so that you can directly see the image or whatever it is. Similar to that, this autonomous underwater vehicles will move from one point to another point depending on the density of information in the particular area and collect the information and send it to the nearby UWO gateway or cluster head, whatever I said in the previous slide, and that sends the information to the surface station for further processing. Okay, so it has the ability for self-configuration, adaptive sampling, and so on. So this is the advantage. I'll show you one more 3D environment where AUVs are placed. Okay, so yeah, this is the diagram where you can see we have anchored the nodes. Yes, we have anchored the UWO nodes, that is underwater sensor nodes, and also we have AUVs here, some AUVs, so that it is always moving and it is collecting the information, okay, and sending the information to the surface station through your acoustic link. Acoustic is sound link. Okay, so if we have a solid line, it is RF link. Okay, if we have this kind of lines, it is acoustic link in this case. Okay, you can observe here. Okay, so what is the main aim when we have or when we consider a sensor network in water environment? The main aim is to collect the data. We need to collect the information because nowadays, yeah, since it is linked to your FDP data science. Okay, so collecting the data is very much needed for data processing. Okay, and also this information, whatever is collected, can be combined or can be linked to your data science or machine learning for a better perspective, perspective, and modify the information in such a way that it is directly available to the user so that we don't encounter with errors or different types of problems. So we can have, yeah, obviously we can have the data science concept, the machine learning concepts after collecting the data or before collecting the data if we model the information properly, and we can have a better network out of it. Okay, better network. Yes, moving on. Yeah, I was saying we have linked, that is the underwater wireless or acoustic sensor networks is linked with the different layers which are present. So we have the medium access control layer. So what is medium access? So before sending the data, we are trying to sense the medium or the channel. Basically, it is channel. Okay, so there has been intensive research on MAC protocols for ad hoc and wireless terrestrial networks, but not for underwater networks. So that is why, yeah, this medium access protocols, control protocols can be modified for our underwater communication, and we can use this layer to have a proper communication between the different points. Okay, our source to destination, we can say. So we have two types of protocols in our MAC. This one. So one is CSMA based protocol and CDMA based protocol. CSMA is carrier sense multiple access. Almost everyone knows this. And also code division multiple access protocols can be used. That is, we sense the carrier before sending, and we send the data in form of codes. Okay, so all this can be merged, but most of the work have not been done for underwater environment. But obviously, this can be a research gap as of now, and we can model it properly, and we can use this protocols for underwater communications. Yeah, these are some of the open research issues with respect to your MAC protocol. One is in case of CDMA, if CDMA is adopted, it is necessary to design access codes with high autocorrelation and low cross correlation. So we need to have the information within the network. We should not go outside the network and try to fetch the information. If we do that, we will be having some problems with respect to communication, and sending of information is not possible, is not practical in some cases. So yes, second research issue can be It is necessary to design low complexity encoders and decoders to limit the processing power. Okay, so and finally, the distributed protocols should be devised to reduce the activity of a device when its battery is depleting. Yeah, yes. So battery concern is one of the major issue. So energy saving concepts can be adopted here when we have this kind of limited usage energy concepts. Okay. But one thing, we should not compromise on the network because we need to have a proper communication, but we need to have a lesser energy consumption. Same as what we think about our mobile phones. We'll charge it for 1 hour and we expect it to be available for 2 days. Okay, so that is how. So nowadays, sleep scheduling and the different active mode, passive mode, different concepts are coming with respect to power consumption. That's a different new topic, that is energy efficient sensor networks. So that is one more different topic. Yeah, we can discuss on that later on. Okay, so yes, with respect to network layer. Okay, with respect to network layer. So basically, network layer is used for having a better routing protocol. So whenever I say a sensor node, so consider this as a cluster head. Okay, so directly sending, if directly sending the information will cost 2 joules of energy, but consider having or sending the information in multi-hop fashion may cost 0.5 joules and 0.5 joules for each hop, then this is preferred, not losing 2 joules, because energy is very precious in a sensor node. So we will go with this routing. Okay, routing plays a very important role. So the network should be configured in such a way that a proper networking or proper routing protocol is to be used. Okay, so that is very, very important. So yeah, there are several drawbacks with respect to suitability of the existing terrestrial routing solutions, because we have many routing solutions for terrestrial environment, but very less protocols or solutions for underwater environment. But nowadays we are coming up with different protocols, routing protocols called as vector-based forwarding, where we try to have the information of that particular sensor, and in multi-hop fashion, by calculating the different energy scenarios, we try to pass the information and so on. Okay, so basically routing protocols are divided into 3 categories: proactive, reactive, and geographical routing protocols. So some of the examples of proactive protocols can be DSDV, which is very famous, Destination Sequenced Distance Vector Protocol. And with respect to reactive, we have one more. It is AODV. It is Ad hoc On Demand Distance Vector Protocol, and geographical routing protocols as well, where we have some routing algorithms called as greedy face greedy. Okay, so it is like a pure aloha protocol. So what is a pure aloha protocol? Whenever the data is available at the source, it tries to send. Okay, similar to that, we have a geographical routing protocol named greedy face greedy. Okay, so it is expecting a data in a much faster way. Okay, so that is one of the geographical routing protocol. Okay, so some of the open research issues with respect to network layer for underwater acoustic sensor networks can be the delay sensitive applications. For delay sensitive applications, there is a need to develop algorithms to provide strict latency bounds. Okay, so we need to have a very small delay. For delay insensitive applications, there is a need to develop mechanisms to handle loss of connectivity. Okay, so that is very important. We need to be connected with network, or else this uh, FDP is not possible if I'm not connected to a proper network today. Okay, so accurate network modeling is needed to better understand the dynamics of the data transmission at network layer and so on. Okay, so all these things are needed, and these are some of the open research issues with respect to network layer. Okay, in connection with acoustic sensor networks. And yeah, Some more are low complexity acoustic techniques to solve underwater localization problem, because without knowing the location of the sensor node, no other processing can be done. Okay, we need to know the location first and try to have the different applications what I was talking about. So mechanisms are needed to integrate AUVs in underwater networks to enable communication between sensors and AUVs. So in particular, basically information available in AUVs could be exploited to minimize the signaling needed for reconfiguration, because AUVs will be always moving, okay, from one point to another point. Okay, so whenever we have a high density data, that will collect and send it to the offshore environment, which is placed above water. Okay, so and all these research gaps can be considered, and with a better routing protocol, that is correct, that is mandatory. Okay, and finally, with respect to transport layer, linked to our uh, underwater acoustic sensor networks, we need to take care of flow control and congestion control. So we need to have a proper regulatory configuration, okay, so that the data which is coming from the sensor or sender should not lose its efficiency or lose its information. So we need to have a proper flow control. We can have a buffer for it. So one data can come, then when it is released, then only the next data should come. So consider we have 1, 2, 3, okay, 3 packets of data. So we can have a buffer. So first 3 can come, go to the sender, 2, 1, and so on. So all this should be considered when we have flow control and also congestion control as well. So the buffer should not receive the data or the packets which are beyond its capability. Okay, so if it can receive 10 packets, it should just ask for 10 packets, not for more than that. Okay, so yeah, accurate estimate of round trip time can be considered when we have this control issues. Okay, that is with respect to transport layer. Yes, these are the some of the design principles which we need to follow when we try to have an implementation of underwater acoustic sensors. So yeah, shadow zones. So as I said, it is a deep water environment where routing is very difficult, where the transport layer faces a lot of problem. Okay, we need to have a minimum energy consumption because the battery power is limited. Battery power is limited in water environment. We need to have a rate based transmission of packets. Okay, so at a particular rate only, to avoid the congestion control. At particular rate, we need to send the data so that all the information is passed or all the packets is sent to the other end in an efficient manner. So out of sequence packet forwarding can also be used, because see, whenever we are talking about wireless communication, we always go with connection less protocols. Okay, connection less protocols. So if it is connection oriented, we will define a path and all the packets move in a sequence. Consider I want to send 2, 3 packets. Okay. So if it is connection oriented, the receiver will also receive in this form, that is 1, 2, 3. But in connection less protocol, 3, 1, 2 packets can be received or may be received because it is a wireless medium. So out of sequence packet forwarding can be considered since it is a wireless medium. So timely reaction to local congestion is very much necessary, because congestion creates problems. Okay, if the bucket is full, then water is spilled out. So similarly, if the buffer is full, the packets will be dropped and we will lose the data. So timely reaction is very much necessary for local congestion. The cross-layer interaction based protocol operation should be considered. That is to have multiple layers of TCP/IP. Okay, TCP/IP. So we have some different layers: physical, data link, network, transport, application, and so on. So cross-layer based protocols can be used so that we can send the information properly. So finally, our aim is to send the information properly. Then only we are communication people. Okay, that is why our branch is there. Okay, so we have to have a reliable communication, and we have a selective acknowledgement based loss recovery. So if the packet is lost, we need to get an acknowledgement so that we can try to retransmit the packet again. So all those things can be considered here. Okay, so these are some of the design principles. So the open research issues with respect to transport layer can be a new flow control strategies can be devised to tackle the high delay and delay variance. A new effective mechanisms tailored to the acoustic channel need to be developed to efficiently infer the cause of packet loss. A new reliability metric definition need to be or can be proposed, okay, based on the event model on underwater acoustic channel model. Okay, these are the research issues with respect to our transport layer linked with underwater acoustic sensor networks. And also continuing, the effects of multiple current events on the reliability and network performance can be studied. It is necessary to model loss of connectivity to devise the mechanisms to have a lesser delay. Okay, so that can be possible. It is necessary to devise solution to handle the effects of loss of connectivity caused by shadow zones, that is deep water environment areas and so on. So all these things can be a research gap for underwater wireless or underwater acoustic sensor networks with respect to transport layer. So these are some of the research areas where we can work considering all the three layers what I just discussed, that is MAC, network and transport layer. So one thing is optimum clustering of underwater acoustic sensor networks may be possible, that is clustering of the particular region. Okay, so consider we have more data here in this part, so more sensors can be embedded, only some few sensors can be kept away from that particular area to monitor and so on. So optimal clustering is one of the important research area. And second thing is topology control of three-dimensional underwater. So we have a very good three-dimensional underwater environment model where we have the sensor nodes, we have the AUVs to collect the information and send it to the system which is present offshore and so on. So have a proper topology control so that we can have a better placement so that the network works fine. Okay, and we meet the purpose. Okay, and we have multipath virtual sync architecture for underwater sensor networks. We can have that. Okay, since we come up with multipath fading and so on. Okay, so we can have a better architecture. We need to have a time synchronization. Why? Because whenever the sensors are trying to communicate, when and if it is in synchronization, the information is properly conveyed. If it is out of synchronization, this may move outside the boundary of your area, your network area, and there this will cause problems because this sensor cannot send the information to that cluster head. Okay, we need to have a proper time synchronization at every or at some interval at least, so that the network will be working properly. Okay, and yeah, this is one of the major research area where channel modeling can be considered, because channel is the medium which is connecting one sensor node with the other sensor node. So channel modeling is very, very important. So when we have channel modeling or when we consider channel modeling, we try to consider all the parameters like sending of information, having a proper bandwidth, having the best communication medium, having the best routing protocol, having a more optimized congestion control, have a very good flow control, and so on. So all these are some of the research areas where we can proceed, or where we can go through with the underwater communication. Yes, so these are some of the information which I wanted to convey to you today. So what I have done is I have given an overview of underwater acoustic sensor networks where we have seen different research gaps, so that the research gap, the aspiring PhD pursuing students can pursue their research in underwater wireless sensor network or acoustic sensor networks. And also we can go with optical sensor networks because it is trending nowadays. But provided we need to have a proper modeling of it, and that is possible only if we model properly. But RF is out of the box technology where this doesn't support the underwater communication properly. So these are some of the references which I used, and I have used many more references, but some important references I have shown here. And yes, thank you for your time. And if you have any questions, please ask.
Participants, you may feel free to ask any questions. Thank you, Yashwanth, for your wonderful session. I hope a deep insight would have been gained by the participants about underwater wireless sensor networks. Thank you again, Yashwanth.
Thank you, ma'am. Thank you.
Dear participants, now we are standing at the end of our 3 days virtual FDP on data science and networking. As a part of our valedictory function, may I request Dr. N, Head of the Department of PNC, Rajiv Institute of Technology, Hassan, to share his views about the workshop.
Thank you, madam. So I'll just try to provide a very brief report regarding this FDP. So I'm very happy that the Department of Electronics and Communication Engineering, Rajiv Institute of Technology, has successfully completed these 3 days of FDP on data science and networking from the dates 25th to 27th of August 2022. So on this occasion, I wish to share that for this FDP, we received around 190 registrations that included the participants from the state of Karnataka, Kerala, Maharashtra, as well as from Tamil Nadu. So among 190 registrations, there were 24 students. I'm very happy with that. So in each of these sessions, around 90 consistent participants. So on behalf of the management, principal, and the organizing committee and the faculties, so I thank all the participants. So I personally wish to thank all the participants for your presence, support, and patience listening. So I hope this FDP has conveyed you a good amount of knowledge. So further, I want to extend my thanks to the coordinators, Mrs. Ambika Madam and Mr. Ravi LS, and also to all of our faculties who helped us in bringing this FDP to the reality, either in the direct manner or in the indirect manner. So once again, I would like to thank our previous resource person as well as participants. So thanks to one and all.
Thank you, sir. The day 3 feedback form, it has been shared in the chat box, so please go through the same. And also, dear participants, the e-certificate for the 3 days virtual FDP, it will be available in 2 to 3 days, and the certificate link, it will be available in the WhatsApp group. So I request all participants to stay in the group until the procedure is going to be completed. And also, final feedback form will be there, and it is going to be shared in the WhatsApp group. Thank you, one and all. We look forward to receive the same kind of cooperation in our future ventures also. Thank you, one and all. Have a good day. Thank you.